right, let's start. Okay, let me double check. No one is in meeting room. Okay, now a ductile material is a material that can be stretched or pulled into a wire. And then here says, okay, let me put a laser pointer. A brittle material breaks easily. You know, a ceramic cup is a brittle material. If I drop my ceramic cup, wow, good luck to me. Okay, or you know, some people buy expensive iPhones. The screens are made of glass. Glass is brittle. If you break your, if you accidentally drop your iPhone on the floor, your heart will break into pieces because your iPhone screen will break into pieces. Okay, let me admit one more person. Okay, let me mark attendance for that person first. Welcome, Jeremy. Hang on, it's Jeremy. Jeremy, is that your name? Because I can't find your name on my attendance sheet. What should your name be? Whoever just
changed already.
okay. The thing is, when y'all change, I can't see who changed his name. You know, can you tell me your name, please?
Bernie.
Oh, thank you, Bernie. So I mark as present. Okay, welcome, Bernie. All right. So we were talking about ductile material. Okay, now brittle material will break easily. Okay, if you drop your iPhone screen, the iPhone screen will break. Now then I have three materials here. I got material X, material Y, and material Z. Okay, then I pull them. Now in case you're wondering what is the difference between ductile and, okay, never mind. Later I'll talk about another word called malleable. Okay, later I'll talk about that. So if you look here, pulling force, if you pull this way, all right, this is the shape, and this is the shape, this is the shape. So which one is the most ductile? Now, ductile, first of all, means can be pulled into a wire. You can pull it easily, it will not break. All right, so what do you think the answer is? Candy, let me mark attendance from Candy. Hi, Candy. Candy, what is your name? Can you unmute yourself and let me know your name? Is it Candy Tan's child?
Yeah, I'm using another computer.
No worries, but I need the name.
Natania.
Hi, welcome. You present first, Natania. Did I pronounce your name correctly? Natania?
Yeah.
Okay, thank you, Natania. I just marked your attendance ready. All right, we just started question 1. Okay, now we were saying ductile means you pull. So which material is the most brittle? Can you type in the chat X, Y, or Z? It's okay to get the wrong answer because we are all here to learn. If you get everything correct, then no point attending tutorial, right? So which one is the most ductile? All right, thank you for your response, Harvard. The rest, okay, so you all have different answers. Okay, now ductile means you can pull it into very, very, very thin wires. So you look at this, which one looks as though it's going to be pulled very easily into thin wires? So obviously you can see a sharp corner here. So Z can be pulled into very, 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 very thin wire. So Z is the most ductile. All right, Z is the most ductile. Then the one that is most brittle, you cannot pull it. When you look at the shape, it breaks already. All right, so X is the most brittle. So the answer is D. All right, is that okay so far? So you have to know that, okay, this part you can see that it is put into thin wire already. Okay, what it means that, let's say you have something and then you start to pull upwards and pull downwards. Then it becomes a long, actually I should be drawing one continuous material like that. All right, then when I pull it, it becomes something very thin. All right, so I will say it's very ductile. Okay, so it's a little bit like noodles. If you've seen noodles making, they pull the noodles, right? And then from noodles become very, very fine bihun, very thin noodles. So it's that idea. So ductile means you can pull it into very, very, very thin wires. So Z is the most ductile. Then the one that is most brittle start with B, it reminds you of brick. All right. Oh, don't like this. Okay, this. Okay, also let's start with letter B and B. Okay, so this one will break easily. Okay, because it doesn't even change its shape. Okay, it stays the same shape. That means it's going to break. So this one will be the most brittle. So X is actually the most brittle, meaning it breaks. Okay, now let me revise these two terms. These two terms are important. You're going to learn, you're going to use this all the way until set 4, O-level exam. All right, if ever they ask you about ductile, malleable, please don't get it wrong again. So ductile, right, means you pull into thin wires. So here we're talking about very, very thin wires. Okay, then malleable is hammer into shapes without breaking. So notice that both words, right, has the word without breaking and without breaking. All right, it's a common words here. Okay, but then what is the difference is one, you're pulling it. So if I were to draw it, right, ductile is actually, let me change to a pen. All right, ductile is you pulling it, pull. All right, and here is pull. Malleable, right, is you compress, you push it. You push it in and you push it in. You want to change its shape by compressing it. Okay, so that is the difference. So if you were to look at my camera, ductile means you pull it. You want to pull it to become thinner and thinner and thinner. It's like pulling a noodles. All right. Then malleable is you push it in to change its shape. Okay, so it's just different direction. Okay, so gold, right, is the most malleable metal. So you see here, this is a piece of gold. If you can find from under the ground, you are rich. Gold is a natural metal. All right. So if you take a hammer, you hammer until it becomes a flat piece of gold foil. All right. That means it's malleable. So malleable is hammer. You're pushing in, you're pressing it in. Press. All right. So I'm sure you have heard of people, those people who are rich, they put gold foil in their food. All right, for example, chocolate pieces with gold foil, very thin gold foil that you can eat it. All right, it's really real gold, but it's a very, very, very thin layer of gold metal. All right, that you eat it. Okay, for me, I rather wear the gold around my neck than to eat the gold. Okay, so this one is hammer, so push. All right, pushing it in. So I use the word malleable. Malleable is you can be hammered into different shapes without breaking. I can push it in and hammer into different shapes. Now, ductile, right? So this is a material. I pull it. Okay, I pull it and make like thick noodles become thinner noodles. Okay, so ductile is about pulling it without breaking. So that's the difference. All right, one is pushing it, compressing it. One is pulling it apart. Okay, next, for question 2 is about vernier calipers. We also later have another question on micrometer. These are all measurements. All right, let me double check no one is in the meeting waiting room. Sometimes people get trapped in the meeting room, waiting room, I mean. All right, so the diagram shows two types of zero error. So there's positive. Let me maybe just highlight it in yellow. So I have positive zero error. All right, I also have negative zero error. So there are two types of zero error. I have some slides to teach, revise this with you subsequently, next few slides. Okay, so if it's positive error, actual reading will be bigger than the actual value. So for positive error, right, you need to do minus something. Negative error, you need to add it in. It's the opposite. So if it's positive, positive means plus, right? But you must go and minus it. If it's negative, negative means minus, right? But you go and plus it, opposite. All right, so I'll show you the examples later. Now, there is something wrong with these two diagrams, so I don't want to talk too much about it because when I look at the drawing, if you look carefully, I cannot even find two lines that are exactly straight. All right, so I would like to actually skip this question. I go to my own slides, okay? Now, this is a vernier caliper. So vernier caliper, this part, right, can be moved. All right, so you can move it. Then the main scale is fixed. You cannot move it. Main scale is like a ruler. You know, you have 0, 1, 2, and then 3, 4. I have 5 here, 6, 7, 8, 9, 10. So this is the main scale. Okay, maybe the laser pointer. This is the main scale. Then the vernier scale is this part. There are some numbers here. This will move. Okay, this is one whole piece. It will move. So you pull it on the right or left, depending on the measurement All right, so whatever you measure, you either put it here or put it here, depending whether you're measuring. Let's say you want to measure the inside of a container, inside of a beaker, you put it here. If you're measuring the outside of a beaker, then you put it here. Okay, so let's see how to read the measurement. Now, I have a YouTube video here. You can click on the link. I have extracted it as a picture so that we can go faster. So this is called positive zero error. This is negative zero error. Now, how do I tell? Now, first of all, this part is the vernier scale that can be moved. This actually, all right, vernier scale. The main scale is the one that underneath that cannot be moved. All right. So this is the main scale. This is the vernier scale. Okay, vernier scale will be moved. All right. Now, if you have a 0 on the right-hand side of this 0 is on the right? You look at these two 0. This 0 is here. This 0 is here. If you have 0 on the right, I call it positive error. If you have a 0 that is on the left-hand side, all right, this 0 is on the left, is negative error. So I'm going to write annotate here to remind you. So always look at this 0, this one. All right, this 0 is on the right. Okay, right of the other 0. So if it's right, then it will be positive 0 error. Okay, then when you have this 0 on the left, okay, left of the other 0. Okay, then it means that it is a negative 0 error. All right, can I have a check that, can you type in the chat, how many of you have gone through this in your school, how to read positive 0 error, how to read negative 0 error? Can you type yes or no? Yes means your teacher has covered it. No means your teacher has not covered it. Can you type into the chat, please? Has your teacher covered how to read vernier calipers, how to read micrometer? Thank you for responding. Oh, most of you, okay, very few yes. Some say no, but my father taught me, must give tuition money to your father. Give him a treat, treat him the ice cream. Okay, your father free tuition teacher at home. Must thank your father. Okay, thank you for responding. So most of you are no, all right? So no worries. So you see, I'm going to highlight it. So this, I highlight in yellow. This, I always look at the bottom 0, the bottom part. Okay, so there are 2 0. I got 1 0 on top and 0 below. So I'm going to put laser pointer. So you see there's a 0 below, there's a 0 on top. Here there's a 0 below, there's a 0 on top. Then you always focus on the 0 below. All right, this 0 below. If this 0 below is on the right-hand side, then it's positive. All right. And if this 0 is on the left-hand side, this is left, this is right? Okay, then it's negative. Are you able to follow so far? So you must first identify, is it positive error or negative error? All right, so let me highlight in, okay, hang on. So if you have right-hand side, then it'll be positive error. Okay, if you have left-hand side, then it'll be negative error. Okay, so what I mean by right and left, I hope you all know. That means if, let's say, for example, okay, for example, you have 1 0 here, and then you have another 0 here, and there's always a 0 below and a 0 on top. Okay, if you have 0 on the, this is left, right? This is right. In terms of positioning, this is left, this is right. So if it's on the left, all right, then negative 0 error. Then here would be if you have 0 here, all right, then another 0 on top, then this 0 is on the right, this is on the left. So always look at the bottom 0. This 0 is on the right, therefore positive 0 error.